Let us see some examples related to the absolute value and its properties. So, the first example, determine the set A. So that the set A is, it contains a real number x such that two x minus 1 is same as modulus of x minus 5. So simplify the equation and then find out the values of x for which this expression holds. So consider the expression which is 2x minus 1 is modulus of x minus 5. So here it is a modulus of x minus 5 and on the left it is not absolute value function. So how to simplify this? So we can use the property of modulus. We have seen that if A is less equal B, then it implies that A square is less equal B square, and it is also equivalent to root A is less equal root B if A and B are positive, right? So we can square the both sides. So it will be 2x minus 1 square, which is modulus of x minus 5 square. And again we have seen the property of modulus, that modulus of a square is same as a square, right? So this can be 2x minus 1 square is equal to x minus 5 square. So expand the brackets. It will be 4x square minus 4x plus 1 is equal to x square minus 10x plus 25. Now simplify the things. It is 3x square plus 6x minus 24 is equal to 0. That means it can be x square plus 2x minus 8 equal to 0. So is it possible to factor the polynomial? So we can write it as x square plus 2x plus 1 minus 9 is equal to 0. Now it is complete square. It is x plus 1 square minus 9 is equal to 0. So x plus 1 square is 9. That means taking square roots on both sides, x plus 1 will be plus or minus 3. So x is equal to minus 1 plus or minus 3. So what can be the possible values? So the possible values will be minus 1, minus 3, it will be minus 4, and minus 1 plus 3, it will be 2. So x can have only two values, either minus 4 or 2. Therefore, the set A, which contains the real number, which real numbers? Those satisfies the expression will be minus 4 and 2. These are the only real numbers. So second example, determine the set B equal to, it also contains real numbers such that 3 times modulus of x is less equal to minus x, and sketch it. So by using the properties of modulus function or the definition of modulus function, we have to simplify the expression. So we consider the expression 3 times modulus of x is less equal to minus x. Again, on the left side it is absolute value function, and on the right side the absolute value function is not there. So we can use the same result or same property. So we square the expression on both sides, so it becomes 9 times modulus x square is less equal to minus x bracket square. And since again modulus of a square is same as a square, so it can be 9x square less equal to minus x square. Now expand the bracket on the right. So 9x square is less equal, it is 4 minus 4x plus x square. So how we can simplify this? It can be 8x square plus 4x minus 4 and is less equal 0. So this can be simplified into 2x square plus x minus 1 is less equal 0. Now can we factor the polynomial of degree 2? So yes, I can factor 2x square plus 2x minus x minus 1 less equal 0. Is it right? Yes, it is right. Yeah, it is right. So it will be, if I take 2x common from first two terms, so it will be x plus 1 and then minus 1, so it will be x plus 1. Therefore what we get from this expression, we get that x plus 1 into it is 2x minus 1 less equal 0. So finding the values of x that satisfy this expression will be same as finding the value of x satisfying this expression, right? So now this is product of two quantities and which is non-positive, either negative or 0. So let us see, x plus 1 into multiplied by 2x minus 1. The quantity is less equal 0. The quantity is less equal 0. So it is a product of or multiplication of two quantity, and it seems it is non-positive. That means it is either negative or equal to 0. So when the product of two quantity is negative, that means one of the quantity is 0. Sorry, one of the quantity is negative and other quantity is positive. So we can have two cases. So first case can be if x plus 1 to x minus 1 is equal to 0. So let us check if the product is 0. So what happens? Okay. So let's see, if the two cases can be, suppose this quantity is positive and the other quantity is negative, is greater equal 0 and 2x minus 1 is less equal 0. So check simplify this, x is greater equal minus 1 and 2x is less equal 1. That means x is greater equal minus 1 and x is less equal half. So minus 1 less equal x less equal half. So it is one of the possibility, the case 1. And the other case can be, so here we consider the first quantity to be greater equal 0 and second quantity to be less equal 0. So now if I consider the first quantity to be less equal 0 and the second quantity to be greater equal 0, so whether I am getting some value of x. So x is less equal minus 1 and 2x is greater equal 1. That means x is less equal minus 1 and x is greater equal half. So such kind of real number does not exist which is less than minus 1 and greater than half. So it is not possible. I cannot have a real number which satisfy both the conditions. That means it can be greater equal minus 1. Sorry, it can be less equal minus 1 and it can be greater equal 1 half. It is not possible. So what should be the case? Therefore, we should have x should be greater equal minus 1 and less than 1 half. Therefore, what was the set? Set B was that it was collection of real number x satisfying the expression 3 times mod x less equal 2 minus x, and it is nothing but collection of real numbers for which x lies between minus 1 and half. So it will be the interval closed at minus 1 and also closed at 1 half. So while sketching this part on real line, if this is the 0, if this is the minus 1, it is plus 1. So we should have this part greater than minus 1 and less than half closed at both the sides. So set B will be this part from minus 1 to half. The next example, example 3, determine set C, which is collection of real numbers satisfying the expression. Now, if we consider the expression, that is restriction on real numbers, that is to be included in set C. So if we consider the restriction, which is absolute value of x minus 1 should be greater than absolute value of x plus 1. So again the both sides, left side and right side, will having the absolute value function. So how to remove this absolute value function from both sides? We can square both sides and use the property of absolute value. Therefore, by squaring on both sides, I can have x minus 1 square greater than absolute value of x plus 1 square. So by the property of absolute value, the modulus absolute value square will be same as square of the quantity, and on the right side also. Right. Now simplify simplify the expression. It is x square minus 2x plus 1 is greater than x square plus 2x plus 1. So x square get cancels, plus 1 get cancels, so it will be 4x less than 0. That means x less than 0. So real number satisfying this expression will be same as real number satisfying this expression. So what are the real numbers satisfying the expression? X should be less than 0. That means all the negative real numbers. Therefore, the set C is real number x satisfying the restriction absolute value of x minus 1 should be greater than absolute value of x plus 1 will be the real numbers for which x is less than 0. That means what? For what real numbers x is less than 0? So the set can be written as the real numbers from minus infinity to 0, and 0 should not be included here. So we should have the open bracket at 0. And if we want to draw it on real line, so if it is 0, so what are the real number? This is set B here, and so the set C should be all the real number from minus infinity to 0, but 0 should not be included. So open bracket at 0, and it should have all the real numbers below 0. The next example, example 4. Example 4 is that determine set which is again a collection of real number satisfying the expression which is absolute value of x plus absolute value of x plus 1 is less than 2. If possible, try to sketch. So now I will consider the restriction, that means the expression that is on the element of set D. So the expression is absolute value of x plus absolute value of x plus 1 should be strictly less than 2. So is less than 2. So can we use the property that the idea of squaring the absolute value? So it will again involve the absolute value. So let us try some other idea. So here it is x, that means x minus 0, and it is x plus 1, that means x minus 1. So we should focus on the definition of absolute value. So according to the definition of absolute value of x will be plus x if x is greater or equal 0, and it will be minus x if x is less than 0, right? Similarly, what can be the definition of absolute value of x plus 1? So it will be the positive value of x plus 1 if this quantity is positive, if x plus 1 is greater or equal 0, right? And it will be negative value of x plus 1 if this value is negative. It means what? The same definition, the value will be plus x plus 1 if x is greater or equal minus 1, and it will be minus of x plus 1 if x is less than minus 1, right? So we can have the partition of real line. The point to be identified should be 0, which is involved in the definition of absolute value of x, and then minus 1, which is involved in the definition of absolute value of x plus 1, right? So it is absolute value is x or minus x depending on whether x is greater or equal 0 or x is less than 0, and absolute value of x plus 1 is plus x plus 1 or minus x plus 1 is depending on whether x is greater or equal minus 1 or x is less than minus 1. So we can have As per the identification of the point -1 and 0 on the real line, we can have three cases on real line. What the cases will be? What the cases will be? X less than -1, right? X less than -1. Then x can be greater equal -1 and x less than 0. X is greater equal -1, right? The half case is here, and x is less than 0. The half case is here, and then x greater equal 0, right? So this is nothing but these three partitions of the real line, depending on the definition of absolute value of x and absolute value of x plus 1. So the first case, if x is less than -1, if x is less than -1, so what happened to the expression star? So star will imply what? If x is less than -1, that means x itself is negative. So by definition of absolute value, if x is negative, the absolute value of x will be minus of x. So the star will imply the absolute value of x will be minus of x plus. What can be the absolute value of x plus 1? If x is less than -1, if x is less than -1, so observe that x plus 1 is less than 0, right? From this statement, this assumption, x is less than -1 means x plus 1 should be less than 0. So by the definition of absolute value of x plus 1, if x plus 1 is negative, the absolute value is minus of x plus 1. So it is minus of x plus 1, and it is less than 2. Simplify this: minus x minus 1 less than 2. So it will be minus 2x minus 1 less than 2. That means minus 2x less than 3. So what it can be? X is less than, x is greater than minus 3/2. So for this case, is it true that x is greater than minus 3/2? X is greater than minus 3/2, so it holds. So this can be the case. So the statement is true. Second case, if minus x lies between -1 and 0, so what star will imply? If x is greater equal -1, if x is greater equal -1, so the absolute value of x plus 1 is x plus 1, and if x less than 0, the absolute value of x is minus x. So it is minus x plus absolute value of x plus 1 is x plus 1. So it is positive x plus 1. So does the statement hold? So minus x plus 1 less than 2. So 1 is less than 2. So it is true. And the next case can be if x greater equals 0. If x greater equals 0, the star can imply if x greater equals 0, so star will imply the absolute value of x will be x, and the absolute value of x plus 1 will be x plus 1, and it's greater equal it's less than 2. So it will be 2x plus 1 is less than 2. So 2x is less than 1. So x is less than half. So what we should want? X should be less than half. The statement is true. X is greater equal 0. So therefore the set D for which the real number x such that satisfying the expression. So what can be the real numbers satisfying this expression? It is true for all real numbers. It is not true for all real numbers. It is not true for all real numbers. Right? If I choose x to be 10, so 10 should not be greater than 1 half. In this case, if I choose when my x is less than minus 1, if I choose x to be minus 2, so minus 2 will not be greater than minus 3 by 2. So this case should not be there, this case should not be there. So it should only have from minus 1 to 0. So the set will be from minus 1, closed at minus 1 and open at 0. And on the real line, you can show the set by this way, which is set D. So you can solve some more examples. Determine the sets. Real number x such that satisfying the expression is less than 7. Real number satisfying the expression and one more set is there satisfying the expression absolute value of 2x minus 1 less equal x plus 1. Try to simplify the expressions and determine the set. One more definition is there, the epsilon neighborhood. So the definition is let A is real number and epsilon is arbitrary greater than 0, then the epsilon neighborhood of a real number A is the set V epsilon at A will be collection of real number x such that the distance of x from A should be less than epsilon. Generally the absolute value function, it denote the distance of point on the real line. So we have seen that the absolute we have seen the property of absolute value that x minus a is less than epsilon if and only if minus epsilon is less than x minus a is less than epsilon. That is what if we add a real number a throughout the inequality, then a minus epsilon less than x less than a plus epsilon. So minus a plus a get cancels here. That means on the real line this is 0. If this is point a real number, then the epsilon neighborhood at point a will be this a minus epsilon and a plus epsilon. So this will be the neighborhood which is denoted by v epsilon.